Today, we will answer this geometry challenge, and here's the question. Given this segment AB, now let's draw point B and point C like this. And let's draw segment AB, segment BC, and segment CD, wherein segment AB, BC, and CD are all equal lengths. Now, it is also given that this angle ABC is 96 degrees, and this angle BCD equals 208 degrees. Now, the question is, what is the measure of this angle ADC? At first, I thought this was an easy question until I try it. So, can you solve this geometry challenge? Pause this video right now and see if you can answer this question, because I will show you the answer and the solutions in 3, 2, 1. Alright, the answer, angle ADC, simply equal to 18 degrees. And that is the answer to this question. And of course, the question is, how do we get 18 degrees? I provide 2 different solutions to answer this question. The first solution is by using the brute force. And the second is by using figure manipulation. So now, let's have our first solution using brute force method. Now, in order to use this brute force method, what we're going to do is to name this angle ADC with angle theta. So the goal is to find this angle theta. Also, without the loss of generality, let's make these equal segments be equal to 1 unit. Also, let's connect this point A and C like this. And now, let's call this a segment A. And this AD, let's call this a segment B. Now, let's focus on this triangle ABC. Take note, this triangle ABC is an isosceles triangle. In short, this base angle must be the same thing. Now, we know the angle inside our triangle adds up to 180 degrees. When 180 degrees minus 96 degrees, this will give us 84 degrees. Now, divide 84 by 2, so we have this 42 degrees, and the other one is also 42 degrees. And now, using what we call the law of cosine, we can now get the value of this angle ABC, or this angle theta. First thing to do is to find first this segment AC, or this segment A, and then find this segment AD, or this segment B, and finally, using again this cosine law, we can now get the value of this angle ADC. So let's do that. So given this triangle ABC, using the law of cosine, or the cosine law, we get that a squared equals 1 squared plus 1 squared minus 2 times 1 times 1 times cosine of 96 degrees. Simplify, this will give us a squared equals 2 minus 2 times cosine of 96 degrees. Now, let's get the value of a. Take the square root on both sides. We get that a equals square root of 2 minus 2 times cosine of 96 degrees. So, this is the value of this segment, A. Now, let's focus on this triangle ADC, and let's set aside this result. Again, let's use the cosine law on this triangle ADC. So, we have b squared equals 1 squared plus a squared minus 2 times 1 times a times cosine of 150 degrees, 108 plus 42 degrees. Simplify, this will give us b squared equals 1 plus a squared minus 2 times a times cosine of 150 degrees. Again, we want the value of b, so take the square root on both sides. We get that the value of b equals square root of 1 plus a squared minus 2a times cosine of 150 degrees. Now, let's set aside this result. And finally, using again this triangle ADC, we can now use again for the third time the law of cosine to find now this angle ADC, or this angle theta. Using law of cosine, we have a squared equals 1 squared plus b squared minus 2 times 1 times b times cosine of theta. Simplify, this will give us a squared equals 1 plus b squared minus 2b times cosine of theta. Isolate this cosine theta. This will give us cosine theta equals 1 plus b squared minus a squared all over 2b. From here, take note that the goal is to find this angle theta. So let's take the arc cosine of both sides. So we get that theta simply equal to arc cosine of 1 plus b squared minus a squared all over 2b. Now let's set aside this result. Now we will use our calculator to find the value of this angle theta. So let's have our calculator. Now let's find first this segment A. So segment A simply equal to the square root of 2 minus 2 times cosine of 96 degrees. Make sure our mode is in degree mode. So this is equivalent to just 1.48628 and so on and so forth. So let's store this value on variable A like this. Now how about for B? So B is simply equal to the square root of 1 plus a squared alpha A squared minus 2 times alpha A times cosine of 150 degrees. And this value is around 2.40. Now, let's store this value to variable b. Finally, to find this angle theta, we have arc cosine of 1 plus alpha b squared minus alpha a squared divided by 2 times alpha b. And there you have it. If we click equal sign, we get that angle theta simply equal to 18 degrees. And that is our answer to this question. So using brute force, we get that angle ADC simply equal to 18 degrees. But we are not happy to do brute force to answer this kind of question. So let's have another solution, a cute solution using the figure manipulation. So let's begin. Now here's the given. And take note, we have a lot of congruent segments. So why not? Let's insert an equilateral triangle in this position like this. Now, since it is an equilateral triangle, so all of its sides must be the same thing, like this. Now, let's call this vertex as vertex E. Now, take note, this angle 96 breaks down into 60 degrees plus 36 degrees like this. And all of this angle must be equal to 60 degrees because this is an equilateral triangle. Now from here, let's connect E and C and focus on this triangle EBC. This triangle EBC is an isosceles triangle. In short, this base angle must be the same thing. So 180 minus 36, this will give us 144 degrees. So 144 degrees divided by 2. So both of this base angle must be equal to 72 degrees. Surprisingly, 72 degrees plus 108 degrees, this will total to 180 degrees. Now from here, what we're going to do is to connect this point B and D like this. And let's focus on this triangle BCD. Again, this triangle BCD is an isosceles triangle, so their base angle must be the same thing. 180 degrees minus 108 degrees, this will give us 72 degrees. Then 72 degrees divided by 2, these two angles must be equal to 36 degrees. Now from here, notice some important information. The first one is segment ED is a straight line, for sure. And also, this angle ABD and angle AED are the same thing. They are all equal to 132 degrees because 60 degrees plus 72 degrees, this is 132 degrees, and 60 degrees plus 72 degrees, this is also 132 degrees. Now, also notice that BD is simply equal to ED because triangle BDE is an isosceles triangle because their base angle must be the same thing. Also, AB and AE are the same thing or congruent. Therefore, this ABDE is a kite. And if this is a kite, this segment AD is an angle bisector. So it bisects angle BAE and angle BDE. In short, if we want to get angle ADE, this is half of angle 36. In short, angle ADC simply equal to 36 divided by 2 or simply equal to 18 degrees? And that is the answer to this question. Therefore, given this figure and using two different solutions, the brute force and the figure manipulation, we get an answer that angle ADC simply equal to 18 degrees. And as always, we are done.